Welcome to our first lecture on INFO620 Enterprise Database Systems. And in Chapter 1, we're going to go over some key aspects of database and database users. Our chapter goes over quite a bit of information, but our lecture is going to focus on some of the highlights. And the highlights will focus more on the characteristics of a database, how it contrasts with the file system, a little bit more about things like transactions, advantages of using a DBMS approach, what is a DBMS, and we're going to go ahead and start with an overview of the different types of database and applications available on the market today. So we have our traditional database applications, which store what we refer to as structured data. Structured data is textual data or numeric information. These are traditional in the sense that they are the primary types of applications out there, because most of our business applications, like a retail point of sale system or an accounting system, focus mainly on textual or numeric information. We also have different databases out there called multimedia databases, and this is more and more prominent now because as the internet starts to look more at the use of images and audio clips and video streams, if we just think about YouTube, we know that this is becoming more and more prominent in day-to-day use. We also have geographical information systems, which could be like the GPS, things that store and analyze maps. Also, things like weather data and satellite images. Other types of systems that we use are data warehouses and what we refer to as OLAP systems, standing for Online Analytical Processing. Data warehouses are different from our traditional transaction processing systems in the fact that data warehouses are about looking and analyzing information, not so much as capturing transactions or updating information. Most of the data in a data warehouse is about reading data and querying data for reporting and analysis purposes. We also have different types of applications that focus on what we refer to as real-time or active databases. Real-time refers to the web primarily, not only, but primarily. If we think about it, and most of us have purchased something on Amazon, they look at information real time because they have over 1 billion customers across the world. So they do have to know precisely where the packages are, what the inventory is, what the pricing all is, because people are shopping online 24/7, 7 days a week. So that's what we mean by real-time and active database technologies. So a database is very much a collection of related data. We'll talk about the various types of databases, like the two primary we talk about in class will be a relational database or an object-oriented database. But databases basically take data that is considered related. So the first thing you might ask is, what do we mean by related data? Well, if you could imagine, and one of the examples we'll use in this particular lecture is a university database. So if you're a student and you're a student in a university, the university has a record of you as an individual. They have a record of your classes that have been taken. They also have records of your grades and the prior prerequisites that you've accomplished to move on throughout your program. All of that data, grades, courses, and student information, is considered related. Another example could be what you experience when you go to a retail store. So when somebody is a cashier, for example, is ringing up a transaction, and when their transaction is done, you get a receipt. If you look at the receipt, that receipt contains a bunch of known related facts. And recorded together, they have an implicit meaning. And it means that this particular product in this quantity at this price was purchased at this location at this time on this date, and it was rung up by a specific cashier. All of those are facts, and it's also basically brought together, has meaning to a business. And you can also see how this represents an aspect of the real world. This is an important thing to remember as we go through this course, because we'll talk about various scientific approaches and use different scientific notation to represent how databases interact, but logically it's about how data is created by an organization or a business and how that data is going to be used in a database, whether like in a data warehouse, a real-time application, or a transaction application. And that gets to our last bullet point on this screen, is that all databases are built for a specific purpose. So many organizations have large databases. Some of the largest databases in the world are created by our technology companies. Amazon.com, for example, eBay.com, all have some of the largest databases in the world. And these large commercial databases are usually done and managed through what we call a database management system. A database management system could be something like Oracle. It could be SQL Server, MySQL, Teradata. They're all examples of database management systems. And these systems are a collection of programs that allow us to really create and maintain a database. And you'll see why that's important in just a second. But it provides the ease of use in the collection and management of data. A database in a database management system, we can define it. We can define it with specific data types. A data type could be like character, alphanumeric, or say numeric. Structures could be things like columns, rows, and tables. Constraints are things such as business rules. A constraint could be, say, the entering in a state in the United States in an address. And we know that states are usually represented by a 2-character capital letter combination. And they have only 50 of them. And if that's the case, we could define a constraint in the database to only hold those 50 states of those 50 values. Another component of a database management system is something referred to as metadata. You might see this referred to as the database catalog or the database dictionary, but metadata is defined as data about data. And it provides information about how the database is defined, and it provides descriptive information about things such as tables, rows, and columns in a database. A DBMS also allows us to enable end users to manipulate the data in a database. They could query the data, and a query is pretty much a question posed to the database in a code referred to as SQL, Structured Query Language. SQL allows you to read data, insert data, update data, or delete data. Using SQL also allows you to do things such as generate reports. DBMSs allow us to do things such as sharing information. Sharing information allows multiple users and programs to access the database at the same time. There's a lot of advantages in doing this. Other things that are included in a DBMS is the ability to create application programs. They don't have to, but within a DBMS you have the ability to create programs which manage the queries that access the database directly. And as I mentioned, a query is a mechanism that causes data to be retrieved or causes data to be created, updated, or deleted. A transaction is a concept that needs to be fairly clear for you to understand databases. So one of the aspects of a transaction is understanding that transactions typically occur in applications as part of routine business. If we think about the retail example, let's say that you're purchasing groceries for your home and you are at the cashier and she or he is scanning the products and the products are ringing up on the screen. Well, once the bill is totaled and you get the taxes and payment is received, a transaction is written to the database. When that happens, data is created, but once the data is created, it's also able to be read by others. So that's what we mean by a transaction. Most transactions pertain to business events that happen on a day-to-day basis. Other things in a database include the ability to do protection, such as protect the data and ensure only certain users have access to read, insert, update, or delete data. The other thing the database management system allows you to do is maintain the database. The health of the database has to be maintained by somebody referred to as a DBA or a database administrator. So here is an example of a database. So here we're using a university database. This was the example that we provided a little bit earlier. A university database will contain information about you as a student, the courses you took, and the grades that you've achieved in a university environment. And in a relational database, for example, we could create database records and a collection of information about the student, the course, the section, the grade report, or let's just say your prerequisites. Here's a great diagram to demonstrate what I mentioned earlier. This diagram gives you a high-level view of how users, applications, and queries are used against a database. So users can be different categories, such as programmers, or in the example of checking out at a grocery store, user could be a cashier. They are accessing what we refer to as the programs. And inside the programs, there are queries that are launched when the user wants to accomplish certain things within the application. Queries are then processed and sent to the DBMS software, and they actually go against the data and the metadata database definition to either retrieve data, support inserting, updating, or deleting data, and then that information is sent back to the application to then talk to the user to say this transaction was complete or this transaction was not complete. Going back to the example of a university database, here's conceptually how the data might look in the database. So in a relational database, we have what we refer to as tables. Tables consist of columns and rows. Here we have an example. Let's go for the student table. In the student table, we have columns, which are also known as attributes or fields: name, student number, class, and major. And each occurrence in the student table is called a row or a record. So here we have Smith, student number 17, class 1, major CS. And then we have another occurrence of a student where the name is Brown, student number is 8, class is 2, and major is also CS. So the concept of columns and rows is very specific to relational databases. Some other things to point out in our conceptual representation of a database is a concept referred to as keys. So let's look at the student table, but also let's look at the grade report table. You'll see that both of these tables have a column that is called student number. And the student number is representing the actual student. So if we were to look at student number 17, who we know as Smith, and we look at in the grade report for student 17, we'll see that this student took 2 different sections of different courses and received a B and a C. When we look at the student number in both tables and match them together, that is referred to as a join. That is the ability to take tables and relate them together. That is one of the aspects of using relational databases. Now, there's some advantages of using databases, which we'll go into, but it's important to understand the difference between a traditional file system and a database. Traditional file system is where there's individual files used to support an application. And when we have individual files, it means that each user defines and implements the file needed for a specific software application. There are some disadvantages with using files, such as the fact that maybe only one user can access the file at a time. A lot of the data is duplicated. It's not centrally located. And it becomes very complex to support multi-users at the same time. A database approach allows a single repository to be created. The data is not redundant. It's only stored once, and it can be accessed by various users. The main characteristics of a database is that, the database itself has a definition of the data. It supports some structure around the data, and it provides a level of insulation between the program, otherwise known as the application, and the data itself. Also, databases support multiple views of data. I'll explain what a view is in just a second. And as you could imagine, having the ability to share the data and support multi-users completing transactions at the same time is a huge advantage. If you could imagine yourself in a busy grocery store and imagine that you have 15 lanes open and each lane has 20 people in line. Well, imagine what the service would be in that grocery store if only one cashier could ring one transaction up at a time. It wouldn't be very business valuable, and it obviously wouldn't be very good for customer service. So there's quite a bit of value in allowing multi-user transaction processing. So another benefit of a database is the support of multiple views of the data. There is an object in the database that is called a view. A view itself is a subset of the database, but what's different about a view versus a table is that a view does not actually store data. It has what we refer to as virtual data. Really what a view is a definition of a table that users or applications could access, and the database presents the data to the end user as it was physically stored, but it's actually not physically stored. The benefits of views is that they're very easily manipulated. They could be created fairly quickly, and there's no need to store data redundantly. The multi-views also supports the different views that many different users might need. There could be a variety of functionality in an application where the application needs to see multiple views of data. So again, a database management system allows this to happen through a concept referred to as a view. So a couple of key things to think about when we think about sharing of data and multi-user transaction processing is concurrency and OLTP. Concurrency is referred to as the ability to allow multiple users to access the database at the same time. So if we have 1,000 concurrent users, that means that there's 1,000 people using this application software at the same time. A database management system supports concurrency and also supports the integrity of data as 1,000 users are updating this single repository of data. That's another benefit of a DBMS. Also, this classification of systems is referred to as OLTP, or online transactional processing. So if you think about a point of sale system in a grocery store, that would be a great example of an online transaction processing system. Another example could be the Amazon as a retail site. That could be looked at as an online transaction processing system. Another example could be online airline reservations. All of these are processing transactions. Some further examples of advantages that are gained by using a DBMS include the ability to control redundancy of data. As mentioned before, redundancy of data can be a challenging thing. That means that we're duplicating data in multiple places in a database. And we want to be able to control that, because if we don't control that, there could be issues maintaining data integrity through anomalies that could be created. Some of the ways that we control redundancy is through a design approach referred to as normalization. Normalization is the ability to minimize redundancy in the database, but also design the database to where data is in its purest form and it's not duplicated across tables. So in a normalized database, you have many tables with smaller rows. So the key and the attributes related to the key are usually the only thing that's kept in the particular table. There is a challenge that comes with data normalization, which is that you might have to join many tables together to support an application completing a transaction. The more joins a database does, the less efficiency that could happen in a database, which means that performance might not be good. As you can imagine, if you're waiting on a customer, the last thing you want to do is see an hourglass on your screen waiting for a transaction to process. So there is an approach called denormalization that uses controlled redundancy to improve the performance of queries, which means it may be permissible to repeat data in tables across the database to ensure performance of the database. Some other advantages of using the database management system is that a database management system provides additional structures and techniques to ensure efficient query processing. We do have the ability to create indexes. As you can imagine, an index is like a table of contents for a database management system. It allows data to be sorted in a particular way, so when the query goes to look for information based upon the primary key, it knows precisely where to find it. Buffering and caching are the ability to store things in memory so that each time a query is executed in an application, it doesn't have to be executed from scratch. It may be retrieved from memory quickly because it's a very popular query that is submitted through the application. The other thing a database management system allows us to do is optimize our queries. We'll learn this later in class, but optimizing a query is a talent developers have to focus on, because you don't want to write bad code, because bad code basically translates into applications that don't perform. And performance means impact to business, and going back to our examples, impacts to things like customer service. Now, one of the advantages of using a DBMS is the ability to enforce integrity. Integrity refers to ensuring that our data in the database is clean, that it relates well together, and it conforms to what our business rules are. So when creating a database, we have the ability to create tables that have integrity constraints. One of the integrity constraints is referred to as referential integrity. This is the ability where we have primary keys on all of our tables, and that we can join these tables together appropriately where these joins find matches across the table. If you remember earlier, we gave an example of where a student had a student number, and that student number was replicated in other tables, so we can actually join grade information to student information. This integrity also means that our primary keys need to be unique. Uniqueness is important because if the data is not unique, that means when we join tables together, we could get multiple results. In some cases, the business rules support that relationship being a one-to-many relationship. In many cases, though, uniqueness means that we have a one-to-one type relationship. An example could be that every course record needs to have a unique value for course number. The same thing with students. You'll go into our university, you know that you have a student number to identify you specifically, because we know things like names may not be unique. The other thing we do with integrity is we translate our business rules and we put those and build those into the physical structure of the database. Business rules could be such as we can only sell an item on a certain transaction under certain conditions, or that every single student may only be able to roll in 5 classes at a time. You're probably thinking, well, these are rules, but they're not business rules, but it applies directly to the data, and we could put relationships and constraints in the database to enforce these rules, because that's how the data is created in the business world. The last topic I'm going to touch on is the fact that we've gone through many advantages of using a database management system, but there are times when using a file system is preferred. And today in our web applications, you'll find that some of our web applications are extremely simplistic. And when a application is very simple and we have well-defined applications that we don't expect a high rate of change, it may not be necessary to use a database management system. We also might have what we refer to as real-time requirements. This mainly refers to the ability to provide data to a user that reflects what is happening now, not what happened yesterday or a week before, but what is happening now. And in a web environment, that's extremely important. Imagine trying to make a airline reservation and you bought a ticket and you thought for sure you bought a ticket for a flight that was available, but the data in the database was a day old, and that was reflecting sales from yesterday versus now. So certain applications require real-time requirements. Other scenarios when it doesn't make sense to use a DBMS is when we have embedded systems. So embedded systems are systems that are basically part of the hardware. So for instance, if you think about your iPhone or your Galaxy Android, obviously these are mini systems, mini computers, but they're embedded systems. So they have limited storage capacity. Also, a DBMS is probably not needed if you have the ability, you have no multi-user access requirements. Okay, well, I'm going to wrap up this short lecture for Chapter 1.